All right, so we're just starting the probability unit, and we're going to start talking about different ways that data can be organized and grouped into sets and what we call subsets of sets, all right, which would be just sets of data within a greater set of data, okay? So some of us did this in class, but not everybody did. So what we're going to do is we're going to organize the information that's stated here in words into a picture. So the set A is defined as all the integers from 1 to 10, okay? The set B is a subset of A, so that tells us that the pieces of B will also be in A. So what do we know about A? Well, I could list out all the things that are going to be in A, like 1 will be in A, and 2, and 3, and 4, 5, 6, 7, 8, 9, and 10. Those are all of the integers between 1 and 10. I'm not going to put 9.2 in there because remember, these have to be integers, so we can't have numbers that aren't integers. Set notation is just a list of all of the things that are a part of a set with these brackets around it, indicating that that is a set. That is A, the set A. Okay, now we have subset B. So we already know when we read subset that B's elements are going to be from these. So the elements in B are going to come from here. All the elements of set A that are odd. All right, so I'm not just going to write every odd number. I'm only going to write odd numbers that come from set A because B is a subset of set A. So the first odd number that's in set A is 1. The next one will be 3. We'll also have 5, 7, and 9. And again, in set notation, I'm going to use my curly brackets. Got another subset here. Now I could have a lot of subsets. We could have as many subsets as we want to have. Subset C is the elements of A that are multiples of 5. So I'm going to go back to A. I'm going to find any number in here that's a multiple of 5. So 5 or 10. Okay, so 5 and 10. So what we've got now is we have 3 sets. And 2 of those sets are subset of a third set. So what I'd like to do right now is kind of visualize this a little bit better. We're going to draw a picture. We're going to draw a big box, and we're going to label this box A. This is A. And inside of A, we know we've got subsets. So we'll use this circle B to represent the subset B, and we'll use a smaller circle C to represent the subset C, because I know we don't need as big of a circle for C. And we're just going to start placing elements where they belong. So the number 1, well, I see that the number 1 is in A, so I know it belongs in this box somewhere, but I see that it also shows up in B. It does not show up in C. So I want to make sure that it's inside of B, which is inside of A, but not in C. So I'm going to put the number 1 inside of B. The number 2 only shows up in set A. So I'm only going to put the number 2 inside of the box, but not inside either of our circles. 3 is much like the number 1. It's odd, but it is a member of set A. So 3 goes inside this circle. And hopefully you guys can fill in the rest of this thing on your own. Challenge yourself by pausing it and then testing to see if you can do this correctly. So 4 is not odd and is not a multiple of 5, but it is an integer between 1 and 10, so 4 goes outside the circles. 5 is an interesting number because 5 shows up in A, so we know it goes inside the box. It shows up in B, so we know it goes in that circle, and it shows up in C. So it's got to go inside of both circles and the box. The only space we have for that is right here. So 5 goes in that intersection point. 6 is an even number, but is an integer between 1 and 10. 7 is an odd number in that same set. 8 is even. 9 is odd. 10 is within 1 and 10. It's an integer between 1 and 10, but it's also a multiple of 5, so 10 has to go in here. So this is a good way to visualize everything you're looking at. You've got a picture of all of the data that's been presented. And from this picture and from the sets that have been given, whichever you're given in the problem, you should be able to determine these probabilities. So first thing we're going to have to figure out is what is the probability of B. I'm not going to answer this for you. We'll check it in class, but you should be able to work this out. The probability of B, and just to be clear, we're talking about the probability of B given that we're in A, all right? So I'm not talking about the probability of finding an odd number ever in all sets of numbers. I'm talking about the probability of finding an odd number within A. And we're going to assume the same thing of C. This would be the probability of finding a multiple of 5 given that we're looking at integers between 1 and 10, all right? So you guys can figure those out before you come in tomorrow. That shouldn't be too difficult. But now I want to talk about a new term, which is this word complement, which we have not used within the context of math or probability until now. So what we're going to do is we're going to define the complement of a set. The complement. So the complement of a set is just basically everything that isn't in that set. So everything not in that set. And that's a definition that's going to be pretty important, but I'll give you an example. For example, if I wrote P prime of B, what this means is the probability of the complement of B. What that would be equal to, would be the probability of any number not in set B. So everything not in B over A, because we're still talking about within this set A. So that's what we're going to do here. We're going to first define that set in set notation. So if D is the elements that comprise the complement of set C, let's first look at what set C is. C is defined as all the elements of set A that are multiples of 5. So D is going to be all the elements of set A that are not multiples of 5. So my first one of those is going to be 1. 1 is in set A but is not a multiple of 5. 2, 3, and 4 are all in set A but are not multiples of 5. 6, 7, 8, and 9 are also all in set A but are not multiples of 5. So in set notation, that's going to be all of the numbers that comprise the complement of set C. Now what you guys are going to do is you're going to determine the probability of choosing a number that is in set D. So before you start that, just remember that the probability of D could be written one of two ways. I could write P of D. I also could write P prime of C, because we're talking about the complement of set C. So you should be able to figure out what that is as well. So when you come in tomorrow, you should have an answer there, and we should have some answers here, and we'll check those in class before we start practicing together.